Hello everyone, my name is Osagede John Osamwige, and today I will be presenting Network Intrusion Detection System using machine learning. So today, in the table of contents, we're going to talk about intrusion detection. What is intrusion? What is intrusion detection? I'll give a problem statement. Then we'll talk about the proposed solution and implementation, which includes the SRS and feature analysis, categorization of attack types, different classifiers and their comparison, selecting appropriate classifiers, and we'll talk about the user interface and results, the user interface implementation, integration of ML model and UI, and the final result. Now, about intrusion detection. Intrusion, usually in a secure network topology, access control is established by use of various firewalls, but when some attacker gains unauthorized access to any part of the network, potentially by breaking or bypassing the firewall, that is known as intrusion. Some objective of intrusion includes unauthorized access to data theft, data tampering, denial of service. Now, in an intrusion detection system, the software must meet the following requirements: continuously monitor the network traffic, report statistics about bad and normal connections, and it must be a predictive machine learning model for classification of connections. For the problem statement, I'll be designing the ML model, then implementing the user interface. Then I will integrate both the ML model and the user interface and do a final testing on the available data set. Proposed solution and implementation. So the software requirements, you either need a Windows, Mac, Linux, and for this project, we're mainly using Python libraries. So let's talk about some feature analysis before the software. So some feature analysis includes the identification and analysis of features. So I'm talking about the identification and analysis of features for MO model, the service, which includes the destination service type, duration, the number of seconds of active connection, the protocol type, which is the TCP or UDP, source bytes, which is the number of bytes transmitted by source, destination bytes, number of bytes from destination to source, the flag, which is the normal error status of the connection, urgent, which is the number of urgent packets, the wrong fragment, which denotes the wrong fragments, the land, which is the connection from same host, host 1 or 0. Now let's talk about the list of attack types. So here are the list of various attack types in the types possible in the network connection. Attack, DOS, denial of service, which happens when an attacker sends in large amounts of unauthorized requests to overload the server. Probing, which is the phase of intrusion in which the attacker gathers unauthorized information from web applications, etc. R2L, which stands for remote to local, which is unauthorized access from remote machine, and UTR, which stands for user to root, which is unauthorized access to root privileges in the network. As you can see, here are the categorizations of attack types. And if you notice, each one falls under one of these four. Here, DOS, probe, RTL, or UTR. So here is buffer overflow, guest password, LAN, multi-op, and so on and so forth. So now, machine learning model implementation. So here are a list of classifiers used for building prediction models: Gaussian, naive Bayes, decision tree, random forest, support, vector machine, and logistic regression. So here are the comparison of different classifiers. The training score. Training score is a measure of how well the model fits the training data. A very high training score means overfitting, which means the model is performing extremely well on the training data. While very low means underfitting, which means the model fails to perform well on the training data given. It could be that it was either too simple or it wasn't understanding that. Also, here's a depiction of the training score analysis of all the classifiers, and we see the random forest and SVM, which is the support vector machine, are up top. Testing score is a depiction of how well the model fits the tested data, similar to training score. In this here, we see that the random forest and SVM here still have the highest score. The training time is total time model takes to learn from training data. We see that random forest again and decision tree are the fastest. Testing time is the time it takes for a model to provide output for the test data. And in this one, the logistic regression is the fastest time in this comparison. Now, let's talk about the machine learning model implementation. So, from what we've seen from the above statistics, we can notice that the random forest classifier has outperformed the other classifiers in terms of training score, testing score, training time, except the testing time. Hence, I have chosen the random forest classifier for building the prediction model and use the same for the intrusion detection system. Hence, the model will be saved in model.pkl and will be used for predicting the real-time network data. You use the interface in the result. So here is how the intrusion detection system will look like. Here are the steps involved in um, you. Here are the steps involved in user face implementation. I'll create the rules window using TK enter, place the header label, draw the IDS image, place the operation load and clear buttons, place the text area for displaying the result. Integrating UI and ML model. So the steps involved in integration of UI with the ML model. Outload the saved prediction model using joblib. Basically, it's just following the next steps. But I will say for the integration of UI with the model, we use the joblib extension to invoke the save model.pkl file. So for this one, I'll use the KDD cup dataset as the input for this program. Here's the source of where I got it from. So now I will come here. I will run this. One second. Okay, so I will load the dataset, my training dataset for my intrusion detection system. That's my test file. Mhm. Upon running, you see the total packets analyzed here, the summary, the normal, the probe, the R2R, and the UTR. So from that, it is evident. You can see these are the final results. In the above screenshot that I've posted, we can notice that the application has displayed the total number of packets analyzed and the summary of each attack. We have loaded a sample dataset using the load button, and final result is displayed in the result area. So thank you. I want to extend my heartfelt gratitude to Professor Anu. Her expertise and guidance have been invaluable in paving the way for the exploration of this topic. And here are my references where I got my images from, the dataset, which will be available in the slides when you view that. And yeah, thank you to everyone watching. I appreciate your time.